Welcome to lesson 2.5, Dilating Lines. Now we're going to take two skills that you have. One, dilations, which you learned in lesson 1.6, and two, writing the equations of lines, which you learned in lesson 2.4, and we're going to mesh those two skills together. No joke. All right? It's kind of like if you took a cat and a dog and you mashed those together, you got a cat dog. What? Let's just go into the lesson. So how do you dilate a line? All the steps to dilate a line are right down here. You just have to follow along. So come for the journey, baby birds. We're about to go on it. So, how do you dilate a line? In this example, we're going to read the question and I'll explain exactly what you need to do. Line y equals 2x plus 2 is transformed by dilation with a scale factor of 3, and it's centered at the origin. What is the equation of the line after the dilation? So we have a line, we have a scale factor for our dilation, and we have the center of dilation. All right? So a line is y equals 2x plus 2, scale factor 3, and it's all centered at the origin. How are we going to dilate this line? I'll show you. The first step is to draw the original line, all right, which I've done for you because I'm a nice guy, all right? This is the line right here, and label it. So we're going to label the line right here. This is y equals 2x plus 2. Very important to label it. All right? Check. Step 2. We're going to pick a point from this line and dilate it from the center of dilation. You might remember how to do this. The first thing you do is you draw your center of dilation, which is the origin, 0, 0. And now we're going to pick any point on this line. All right? There's many to pick from. As you can see, there's points all over the place. We're going to pick our favorite point. It does not matter which one. All right, so I'm going to pick this point right here. Right here. Let's use this point. So you might remember to dilate something, you count the distance from the center of dilation to the point. In this case, it's 1, 2. All right, 2 up. I multiply that by the scale factor, so that's 2 times 3, and that gives me 6. So now I go up 1, 2, 3, 4, 5, 6. Starting at the center of dilation. So it was 2 away from the center of dilation, now it's 6 away. And that's where our new point is. So after I dilate this line, the new line will go through this point, and I write down that point. That new point is going to be 0, 6. Now this is where our skills come together. First we dilated a point on the line. Now we're going to write the equation of our new line that goes through the point 0, 6. And that's exactly what we did in the last lesson. Remember, we wrote the equations of lines that go through points. So it goes through this new point. All right? So how do we write our new equation? Well, remember, when it goes through a point, that's our x and y coordinates. So our x is 0 and our y is 6. That's a bad 0. All right? All right. Now, what slope are we going to use? Well, that's a pretty straightforward thing. The slope we use is the same slope as in our original line. So the slope of our original line is 2. So the slope of our new line will be 2. And why? Because dilations make lines parallel. So if you ever dilate a line, they will always be parallel. Always. So that's why we use the same slope. Always be parallel. Okay? So now we just do exactly what we did in the last lesson. We just plug into y equals mx plus b. Let's go for it. Our y is 6, our m is 2, our x is 0, and we'll solve for b. 6 equals 0 plus b. We don't have to, we can subtract 0, but the 0 just goes away and we get b equals 6. So now we'll just write our final equation. Y equals 2x plus 6. And that is the new equation line dilated, our new line after the dilation. All right, and that would be, and let's just graph that out. If we were to graph this line, let's see, it goes up 2 over 1, up 2 over 1. It's centered at 0.06, up 2 over 1, 2 over 1. And we'll just graph it real quick. Boom. Let's get all this craziness out of it. Oh. All right. So as you can see, the two lines are parallel. This is y equals 2x plus 6. We've labeled both of them. They're parallel, and it has dilated away from the center of dilation, right, by a scale factor of 3. That is awesome. Now, I know what you're saying to yourself. That was a little confusing. But I promise you, we're going to do it a few more times. It might work. And you might get it. In fact, I promise you get it. So I got 3 more examples. We'll go through them. Our next example is y equals 3x minus 2. It's transformed by a dilation with a scale factor 2, once again centered at the origin. What's the equation of the line after dilation? Well, let's do exactly the same steps. Step 1, we're going to draw the original line. So it's y equals 3x minus 2. Our y-intercept is negative 2, so that's where we start. We go up 3 over 1 because that's our slope. All right, we're just graphing our original line. All right, draw a line through it. You should probably do this with a ruler. Not probably, you should definitely do this with a ruler. All right, and we're good. Next step, we are going to draw our center of dilation. Once again, it's the origin. And we're going to pick a point on this line to dilate it from. So let's see. I'm going to pick this point right here. Once again, it's close, it's simple. Let's go for it. So I'm going to count how far it is away. So it's down 1, 2. From the center of dilation to the line, it's 2. Now I'm just going to multiply by the scale factor. The scale factor is 2, so it's 2 times 2, and that gives me 4. So now I count 4 away from the center of dilation. 1, 2, 3, 4. And that's the new point it goes through. So our new point it goes through is 0, negative 4. All right, so that's the first stuff. Remember, that's the dilations. That's the things we learned in lesson 1.6, how to dilate a point. We did it. All right, step 1 done. This is lesson 1.6, and we know how to do that perfectly. Now we're going to take that information and write the equation of a line. This is what we learned in 2.4. Same exact thing, not changing anything. So our point is 0, negative 4, so that's our x and our y. And our slope is, let's see, 3. Remember, because the lines are always parallel in a dilation. So our slope is 3. We plug into our formula, y equals mx plus b. So it's negative 4 equals 3 times 0 plus b. Negative 4 is equal to 3 times 0 is 0 plus b. And we get negative 4 is equal to b. We'll write our final equation. Y equals, our slope is 3, 3x, and our b is negative 4. So like I just said, this is just taking your 2 skills, how to dilate a point and how to write the equation of a line, and you mix them together. And that's how you dilate a line. So you should graph this line now. Our y-intercept is negative 4. All right, we go up 3 over 1. Up 3 over 1. Up 3 over 1. And you'll graph your new line. I'm not being specific. And don't forget to label. Don't do what I did. I forgot to label right there. This is y equals 3x minus 2. Y equals 3x minus 4. Yes, that is the ugliest line on earth. All right? Geez. I'm sorry. Just, it just didn't. Anyway, I'm out. Let's do the next one. All right. Our next example. We're going to keep doing these. It's the same thing every time. I just want to get you used to it. I want to give you as many examples as possible. If you think you can get it right now and you're like, easy, by all means, you could stop watching the video. You totally get it. You can do the example problems. But we got 2 more examples. Feel free to watch, all right? So in line y equals 2x plus 1 is transformed by a dilation with a scale factor 2 centered at 3, 2. Notice here that this is not the origin. What is the equation of the line's image? Well, let's go through this again. Step 1, draw the original line, which is y equals 2x plus 1. All right, that's 1. It's our y-intercept. And we go up 2 over 1, up 2 over 1, up 2 over 1. Same thing in the other direction. All right, so we're just drawing our line. That is the first step. Where's my line? Let's draw a nice line now. Boom. Step 2, We're going to dilate this line, starting at the center of dilation, which is 3, 2. All right, you pick any point on this line. I'm going to pick this point right here, and we're going to dilate from this point. So the center of dilation is 3, 2. Here's the point on the line. Let's dilate it. So, step 1, 2. We're going to do our dilation now. We go up 1 over 2. I multiply that by the scale factor, which is 2. So that's 2 times 2 and 1 times 2. And that gives me 2, and that gives me 4. Okay? So let's take a look now. So now that we have our new distances, we just count again from the center of dilation. We go up 1, 2, and then over 4. 1, 2, 3, 4. And that's the new point my line's going to go through. So remember, I just doubled my distances. Instead of going up 1 over 2, I went up 2 over 4 because the scale factor is 2. So this new point is -1, 4. And that's the point that it goes through. Point my new line goes through. New line goes through. Okay? Step 3. Well, we just plug in all our information into writing the equation of a line. So let's see. It's y equals mx plus b, exactly what we did in the last lesson. And we write m, x, and y. All right? It's really easy when you set this all up for yourself, nice and pretty. The slope of our new line is 2. All right? Because remember, when you dilate, the slopes are always the same because they're parallel. And our x and y is this point right here. Now, a big mistake everyone does, that I've seen do this, is instead of using the new point, which is 1, 4, they use the center of dilation. Don't use this. Use the center of dilation here. It's the new point it goes through. All right, we're going to plug it all in. So y equals mx plus b. 4 is equal to -2 plus b. We add 2 to both sides, and we get 6 is equal to b. Write out our final equation because we're not done yet, and it's y equals, we have a slope of 2, 2x, and then our b is 6. And that is the equation of the line after dilation. I think you should all draw it as well after that point. All right, make sure you draw your dilated line better than I draw it. Label everything. Y equals 2x plus 6. Y equals 2x plus 1. And you are done. For the final problem right here, all right, I have it set up. What I'd like you to do is do it yourself. Pause the video now and then come check your answer. All right, I want you to check your answer. I'm just going to write the answer out. Come back and check it. Ready? And go. If you did this one correct, I know you didn't pause the video, you should have gotten this as your answer. All right? That's how you know you did it correct. Now, I'll tell you this. You might notice here that this line is into y equals mx plus b form, so the first thing you should have done was put that in y equals mx plus b form. If you did all the steps correctly, here's your answer. All right, guys, that's it for this lesson. Go kiss your mama and tell her, that was a tough lesson, but I'm glad I learned it because I love my education. Peace.